Hello, today I want us to look at three of the most important rules when we are doing any derivation or when we want to do or to find any derivative. And for this case, we are going to first start with the first rule. And for this case, the first rule is we can have a rule that we normally call the constant rule. Constant rule. Yeah, starts with that. When we talk about the constant rule, it basically states that a constant does not change whenever you find its derivative, because its derivative will always be zero. Like for instance, the rule normally states that if you have, maybe you want to find the derivative of a certain function, and that function is c, like that. So that derivative will always be zero, it will never change. So the constant never changes, so its derivative is equal to zero. Maybe we can try some examples here, and we can have a very simple example. Let me just change the color there. We can have maybe let's say you have a certain constant and you want to find the derivative of a certain constant, which is 5, like that, and it's supposed to be equal to 0 whenever you find its derivative is equal to 0. Let me give you this one. You try find the derivative of this other function. This function is 100 or negative 100. So what should be the answer? And for this case, the answer should always be equal to 0, because the derivative of a constant will always be 0. So that is what we have. So that is the first rule, which is the constant rule that we are talking about today. I want to include another rule here. Maybe let me separate there like that. You can have maybe a second rule, and the second rule, we can basically call it as the constant multiple rule. Constant multiple rule. So what we mean by this is that you may find a constant that is being multiplied by a function. Like for instance, let's say we have something like this. Let's say like you have a function f of x can be given as 4x to the power 2. For this case, we have a certain constant 4, which is multiplying a certain function x squared, like that. So when you have something like this, according to constant multiple rule, when you want to find, maybe let me use a red one, when you want to find the derivative, for this case, it's going to be something like this. Let me first write the rule. According to the rule, we normally say that if you find the derivative of a certain function, and our function here for this case, let's say it's a function that is having a constant, and then like that. So this one, the answer that we are supposed to get for this, we are supposed to have or to just hold the constant, or you will keep the constant, and then from there you differentiate the function. You differentiate the function. So you just hold the constant and then you differentiate the function, like that. And you can have an example here. You can have a simple example, and the example that we can use for this one, we can have something like this. Like let's say we have a certain function f of x here is equals to 3x squared. So that is what we have, 3x squared, like that. So if you try to differentiate this function, so you just need to hold your 3, as you have said, just hold your 3. So you can just hold your 3 there, like that, and then now differentiate the function. Now 3x squared, differentiate it, and for this case you're going to have 3, you multiply that one by For this case, once you differentiate this one, we are going to use the power rule, whereby we are just going to multiply this 3 by this power that you have here. So just going to multiply 3 by the power, and for this case our power is 2, like that. Oh, not that one, not that one, that was the 3. Yes, okay, yeah, we're okay. So yes, you multiply that one by 3. I just change the color there so that it becomes clear. So you just multiply that one by 2, and then your x, you need to subtract a 1 from it, like that. So you're going to have, for this case, if you multiply 3 times 6 times 3, you get a 6 there, and then your x, and then 2 minus 1, able to get a 1, like that. So that means that once you differentiate this one, 3x to power 2, you should be able to get 6x as your answer. 6x is the derivative of that. So that is what we normally call as the constant multiple rule. For this case, it can also be used. Maybe let me give you another one for you to try. Maybe what if you have a certain other function? Let's say you have another function here, and our function that we have here is function f of x. F of x, for this case, f of x is something like 7x to power 3. So you need to differentiate that, and to differentiate that, as we have said, you need to hold the 7 first, then you differentiate the function, and to differentiate the function, you need to drop 3, like that, which is the power, and then on the power you need to subtract 1. So once you subtract 1 from the 3 here, you're going to have a 2, like that. So once you multiply these 2 now, I'm going to find that f of x prime, for this case, is going to be equal to 7 times 3, and then that is equals to 21, like that, 21x squared, and then you have your answer. So that is how you normally apply that rule. So let us move to our third rule. And our third rule is now what we call the sum of the difference, the difference rule. The sum and the difference rule, rule. And what you do for this one is basically a function that is having different terms. Like for instance, let's say like we have f of x is equals to something like 2x plus something like 3x squared. Let's say you have something like that. So how do you differentiate something like this? So what you just need to do is very simple. You need to like for instance, when you're adding or subtracting these functions, we just need to differentiate each part separately. You come to this part, you differentiate it separately, then you also come to this other part and also make sure that you also differentiate it separately. So you're going to have something like this. So f prime of x here, and then you differentiate this one separately. So how do you differentiate it? This is raised to power 1 there, so that means you're going to have this one multiplied by this constant 2 there, like that, 2, and then for this case, once you subtract a 1 from the x, you're going to have like x to power 0, and whenever you raise any number to power 0, it will always be 1. So that means that this number now can now be written as just 2, because this is something like 2 times 1. So once you write it as just 2, it is correct and it is okay. The other one is this one that we have over here. So you need to add, because we had addition here, so you need to add here and move to the next term and also differentiate it. Once you differentiate it, now this power you're going to multiply with this coefficient, which is 3 here. So you have 2 times 3, and for this case, once you multiply the two of them, you're going to find that 2 times 3 here, you get a 6, like that. And then on the x, you need to subtract a 1 there, so that you're left with 1, like that. So that means now you can say that the final answer there is 2 plus 6 x. 2 plus 6x is the derivative of this function. So for some and difference rule, maybe we can do one for difference, because it's not always that your functions will always be positive. Maybe there are times when it is negative, then you need to know how to work it out when it is negative. And for this case, let's say you have a function f of x like that, and our f of x is normally given by something like, let's say you have 4x squared and then subtract 5x like that, subtract your 5x like that. So for this case, these are 4 like that. So for this case, what you just need to do is very simple, the same procedure. You need to differentiate each part separately or each term separately. And for this case, you need to have now your f of x, that is derivative of the function, is supposed to be now for this case differentiated. And once you differentiate it, remember what we said, it is this power that you're multiplying it with this 4 here. So 4 times 2, you're supposed to get an 8 there, and then x, and then these 2 here you subtract a 1. So you're going to have 2 minus 1, which is just 1 like that, and then you subtract 5 here, and for this case 5 is raised to power 1 here. So you have 1 times 5, you have a 5, and then x minus 1, x is raised to power 1. So you subtract 1, you get x to power 0, and any number raised to power 0 is just 1. So that means your final answer can be 8x to power 1 like that, and then you subtract a 5 because it's just 5 times 1 like that, and then you have your answer like that. So that is how you do it. Thank you so much for listening to me.